I'm beginning this video with the contents of this markdown cell opened up so that you can see side by side how a mathematical statement is written and how it appears in the markdown cell. So markdown cells can contain mathematical formatting using TeX. Now that's spelled T-E-X, but it's pronounced TeX. Any text enclosed between a pair of dollar signs, as you see here, will be rendered as TeX. So this is saying take x and raise it to the second power. And you can see that then it's displayed as x squared. And it's easy enough to change. If I want to raise x to another power, such as let's say 5, I can simply do that to change that to a 5, and I can look at how it's rendered, and I see, yes, it is x to the 5th. Now you might ask, what if I wanted to make it x to the 20th power? Well, now you see that this does not display correctly at all. It looks like it's x raised to the second and then multiplied by 0, which is not what we were asking to do. We wanted to raise x to the 20th. So this is something that I'll teach you how to do correctly in this video. And I'm going to use Euler's identity below with different types of formatting to give you a sense of what you can do in TeX. And I'll also discuss a more expansive notebook, Markdown TeX examples, that I link to here that's in the repo associated with this class. And I'll go through the process of how you can access that file through the GitHub option and opening files in Colab again. So that's what we'll be seeing in this video. Picking up where we just left off, we see that x raised to the 20th power, because that's certainly what that looks like over here, is not rendered correctly by the markdown. It looks like x raised to the second power and then apparently multiplied by 0. So in order to fix that, we're going to introduce a very simple concept that you need to be aware of in TeX, which is to, when you have multiple characters that you want to group together in terms of like a power or as a subscript, or like within a fraction, the numerator, the denominator, or put like the square root sign over, you need to use curly brackets to group that content. So if I use a left and a right curly bracket, then you'll see that the 20 is grouped together within those curly brackets. And if I look at how it appears, I see it is x to the 20th power. Now I could go ahead and say I want to raise x to the 20th power, and maybe I want to add some function of another variable y. Like, this is complete and total nonsense, but just to give you a sense of it. So I'll add sine of y. Now, when there's standard functions, standard trig functions, standard hyperbolic functions, there's a lot of things in Markdown where they have a command for it that's very simple. You just need to put a backslash and then the typical thing like sine, cosine, tangent as sin, cos, tan. And when you do that, if you look at how this is displayed, it looks beautiful. It looks like x raised to the 20th power, but the power also has 20 plus sine of y to it. It's the whole thing, because that's all grouped together in the curly brackets. Now you can notice that the curly brackets are not rendered at all. You don't see the curly brackets on this right-hand side. I see x raised to the 20th plus sine of y, but I don't see the curly brackets around it. And in fact, if I added other curly brackets to the sine of y, because maybe I just like for my own visual sense when I look at the markdown, I like to use curly brackets perhaps to group things to make it more readable to me. Maybe I also have like plus cosine of y. And there I'll close the curly brackets. So this content is grouped together. What happens when it's rendered? Well, it just looks like x raised to the 20th plus sine of y plus cosine of y power, right? It's this meaningless expression I'm playing with, but these curly brackets are not shown. And maybe you want them to be shown. In that case, what you do is you just add a backslash to a pair of surrounding curly brackets, and then you'll see the curly brackets have appeared. It's x raised to the 20th plus, and now for whatever reason I decided to use curly brackets for grouping this content. I have sine of y plus cosine of y in those curly brackets. And if I get rid of the backslashes that are over here, you'll see that when it renders it, they're just gone. Those curly brackets are now gone. And you might ask, well, do I need this for parentheses? No, you can actually see parentheses are working here. They're rendering here. But I can't replace, so these curly brackets are extraneous, this set I put around sine and cosine. But let's say that I replace this set of curly brackets by any other type of grouping character you might think of, like a parenthesis or a square bracket. A parenthesis will not render this correctly. It looks complete and total garbage right here. It is just awful, right? We have x raised to a parenthesis, and then we have this 20 plus sine of y plus cosine of y. So the parentheses don't work. You have to use curly brackets. It would be the same thing if I switch this with square brackets. Square brackets are not appropriate. You need to use those curly brackets. So I just want to make that really clear. Curly brackets are used to group content together that is meant to go together inside of a power, a subscript, in terms of numerators and denominators for fractions, the square root symbol. So all that stuff, you're going to see curly brackets showing up a lot as a way to group content that is meant to appear in the same place within a mathematical typeset in TeX, excuse me. So with that being said, I'll just switch this back to x to the second, but please feel free, if you're following along with this video in this file, to play around with this and get a better sense of it. Let's go ahead and look at Euler's identity. So here, this is e, we're writing e to the ipi. I'm going to just show you these different formattings. If we open this up, we see this dollar sign again, $1 around the whole thing. And we see that we put curly brackets around I times pi. Now, pi is the Greek letter pi. And if I want it to render like the Greek letter, I have to have that backslash there. So again, backslash is very special in TeX. It's really saying this is not just some variable, like this is something that should be rendered in a very specific way. So that looks like this. You definitely see that the pi is showing up correctly. And then I just have this bullet list of what all the contents mean in Euler's identity. So this is just some formatting of how you might present an equation and describe all the things that are in that equation or formula. You'll also notice here I have a square root. I want a square root here, and you see here's the square root rendered beautifully, like as it should be in mathematics. And it's very simple in TeX. It's just backslash and then it's SQRT. So it's short for square root. Similarly, we'll deal with fractions with later on in this video. And there it's frac, it's F-R-A-C instead of fraction. So there is some shorthand in some places for what symbols should be. It's pretty straightforward. You kind of get used to it as you play with TeX more often. But at any rate, if we have that backslash SQRT, we now tell the square root with, when we have this curly brackets, what we want the square root symbol to be over. We want it to be over the -1. If you got rid of the square root, let's say I just got, or excuse me, not the square root, the curly brackets, and you look at this, you'll see that it's now just putting the square root over the next symbol that follows, and it looks like the square root of negative, and then we have a 1, and that's not how we want it to appear. We want it to appear like the square root of -1, where -1 altogether is under the square root. So you should really play around with this. The other things that I'm going to end this part of the video with are just describing how to do some display math. What you do there is you use $2. So here I'm actually going to format this differently. I like to have, when I'm doing display math, meaning it's not inline, a single pair of $signs will put the mathematics in line with the other text around it. If you use $2 signs, you're doing a display math, you're putting that math on its own line centered on there. So you see this is Euler's identity is, and then this is the same formula as I have here. I haven't changed the TeX. I've just changed that I've put $2 signs around it. And when I do that, I really like to format it a bit like this, where I have these spaces are extraneous. I'll remove them right here in front of you. I like to do it with the $2 signs on either side and just a little tab here. And it's just like when I open up the markdown contents and I see the math there, visually I know that that is meant to be in this display format. It just reads to me like how I want it to appear with this math on its own line. However, there's nothing to stop you from doing the following, where you could have this on this line like that. And you'll see it does not change how it appears when it's rendered. Over on the left, though, I think it's really kind of hard to read if you start putting all the text together and you just have it as like one long line. Then it's easy to kind of make weird formatting errors and just mistakes because you're not really writing it in the way and style in which you want it to appear. So that's why, again, I just like to have my raw text within my TeX within my text cell, my markdown cell, to be formatted in a way that's consistent with how I want it to appear. And of course, you can also make these things larger. And again, I'm just going to go ahead and fix this while I'm at it. So there's these nice commands, and we'll go over this a bit more in the last part of this video. where we can just make this large, large, L-A-R-G-E. And if you just compare the size of the text here, let's say to up here where I didn't use the command large, you'll see that this is in fact larger in format 3. That's the only difference, is I used large. And you can even, it's really kind of funny, you can do back, and again, that was a command for TeX, so it had that backslash associated with it. And if I just wrote large without the backslash, oh, let me just do that, then the word large shows up, and this looks like nonsense, right? So when you have a command for TeX, like a function, like a trig function, a fraction, a square root, you want to use that backslash to say this should be a symbol, this is something for Markdown or TeX to interpret correctly using the backslash. You've got to use that backslash. So there, anyways, backslash large, let's say I do backslash large with a capital L. It's even larger. And I can also do huge. You can see it's huge there. You can do, it's really ridiculous, but you can do huge with a capital H, and it's huge. It's just huge. And here you can also, let's just go back to large. I'll just show you something else. Sometimes you like to box things, so you want it boxed. So I want to make a box, and I want to box this content. How do I group that content under the boxing? Or under the boxing. Within the box, use curly brackets to group everything. And there's the boxed Euler's identity. So there you go. You can see how to play around with TeX, and some of this stuff is fairly straightforward. It seems somewhat intuitive after you've been doing it for a while. When you're first learning it, it can seem pretty strange, but this is the great thing about these Jupyter Notebooks and about the content I'm providing you here is it's completely transparent. You can just open up any cell at all that I've written, and to see how did Troy make it look like that. You can just see for yourselves. Just open up the Markdown cell and look at how I did it. And in fact, that's what I'm going to do in the next part of this video, which is going to involve these additional Markdown TeX examples. To obtain the file 01_markdown_TeX examples, which is found within the GitHub repo for the Programming for Data Science here, you can simply go to File on Colab, go to Open Notebook, go to GitHub option, go to CU-Denver-MathStats-OER. This is just like the first video I made that was based on getting started with Colab. Press Enter, go to the Programming for Data Science repo, and you will find the contents here. You can select to open this in a new tab, which is what I will do. Of course, you should remember that when it opens, this is something that is housed and stored on GitHub. So if you want to make changes and have it saved in your Colab notebooks, what you need to do is, of course, save a copy and drive. If I go to save, it will prompt me to save a copy and drive. I already have a copy saved in my drive, and I already have it in the place it should be located in, which is within the lectures folder of the 01-Jupyter folder that was in the lectures and assignments folder within my Programming for Data Science repo. So I can actually just go ahead and get it. I already have it in mind, so it's one of my recent files here. And so I will go ahead and click on it there to just open it. But you should go through that process. It's something I talk about in the first video about getting started with Colab. So that at least gets you this file, and now we can start talking about its contents. This part of the video will be an overview of these contents. The best way to learn TeX is not to watch me really talk about it. It's for you to open up a file like this that has lots of examples, and then open up each of the text cells and look at the Markdown formatting in there. And it's specifically as it relates to the text, or the TEX text. And you want to see where I have single dollar signs and double dollar signs for inline or display math. You will notice that here I've also included some tick marks to format this as code so that it doesn't even display as math. It's just, this is how you could communicate what TeX might look like in a raw form for the user if you wanted to display that. So just giving you that kind of idea of how I can incorporate tick marks to say, here's how I can communicate what the TeX is in my text, my rendered text from Markdown. So one thing to just point out or reemphasize is again the use of curly brackets to group content. The fraction operator in TeX is again backslash FRAC. It's something I mentioned a little earlier. And then you just put the numerator in the first set of curly brackets and the denominator in the second set. And then that will render it as the numerator over the denominator. And then you can start seeing that I made, like a 17 divided by 25. And there's this special thing with fractions that they're used so often, and you sometimes want them to be displayed larger, that you can use dfrac for display fraction, and that will make it the size that it normally appears in this display mode where you have used $2 signs, but you want it to be inline. That's just shorthand for display mode fraction. And so you'll just see the difference between that 17 over 25 compared to this other smaller 17 over 25, which is what the typical inline one would produce. You can also play with different commands for sizes, such as large, capital large, or huge. I discussed some of this a little while ago. And then there's also different things like parentheses and brackets, and I pointed out, I believe earlier, if you want to have curly brackets show up, you need to put backslashes on those, but you don't need to do any such thing with parentheses or square brackets. However, if you add a left and a right command, of course with a backslash left, backslash right, before a parenthesis, a square bracket, or a curly bracket with the backslash attached to it, that will do some auto sizing for those so that it looks a little better in terms of how things appear. And so I just show some options of that. I get into grouping subscripts and superscripts and taking subscripts of superscripts and so on. So it's just lots of examples for you to play with just to get the handle on it. I also show some calculus symbols. Again, you should just kind of dive into this and see for yourself how I made all of these things. You see some traditional ones like derivative operators, partial derivatives, gradients, integral signs, summations. This is just useful stuff to know. There's lots of times where you want to use arrows, and so there's, it's pretty straightforward in TeX. You want a right arrow, backslash right arrow. You do a capital R for the right arrow, and then it's a different type of right arrow. It's one that we typically use in mathematics for implies. You want a longer right arrow, it's backslash long right arrow. These are, like I said, pretty intuitive. And you want like you want two of these arrows next to each other, it's right arrow. Some of these stuff seems kind of silly, but there's a logic to this language. And then there's bidirectional arrows, up down arrows, different types of dots like horizontal dots, vertical dots, diagonal dots. And so horizontal dots are C, that's more for like centered dots. That's a good way to think of it. Vertical dots, V dots. V for vertical, D dots, D for diagonal. So a lot of this stuff is pretty intuitive. There's some Greek letters here. I show examples how to do it. It's backslash alpha, backslash beta, and so on. And of course, some of them have their capitalized counterparts, backslash capital gamma, backslash capital delta. These are pretty straightforward things to do. And then I show some more advanced things. I'm not going to get into this in this video, but it's something to really go into because you can really start formatting the text and making things really nice and adding comments with like under brackets and text. Really cool stuff. Highly recommend you go through this and also see how you can do like cases. I really start going into more advanced things like matrices with either parentheses or brackets. It's very simple. It's like P matrix for parenthesis enclosed matrix, B matrix for a bracket enclosed matrix, and then how to do some custom arrays with some other formatting like vertical lines, or do things if you want to display tables of data. Then also some font choices in terms of making symbols that are associated with like the real numbers or the complex numbers, the types of notation that you might use for certain types of operators, or making symbols bold. And this is all good stuff, again, just to know. So this kind of has a lot of reference material, but it's not everything. There's a lot of things you can do in TeX. This is a good place to get started if you're just learning. It's a good reference, and you can add to it. I encourage you to get it, make it your own, put it in the repo, and just add things that you find useful in there, because that's how you're going to learn. Activity 6 is asking you to do some TeX yourself. So part A of this activity asks you to use TeX to typeset Stirling's approximation, the more precise formula according to Wikipedia, using at least two of the above format options. And that is referring to the format options that I showed above for Euler's identity, where it is expected that you will then show Stirling's approximation in a similar manner to Euler's identity, while also using a bullet list to explain the various components of Stirling's approximation. So I'll just do one of the formats in the solution video. You should do another one. The way I like to get started when I'm asked to do something like something else is by first copying and pasting. So I'm going to do that now. I'm going to go ahead and copy format 2. I'll take the middle one. So let's go ahead and take format 2, and I don't need that section heading on it, so I'll just copy that. I did a Control C there. I'll come here, my answer to part A goes here, so I'm just going to go ahead and overwrite that part, and I'll just go ahead and say format 2, display math with bullet list. Now I'm trying to say actually what Stirling's approximation is, and I have to rewrite whatever it is here. I know that needs to change, and I also know that these various bullet points will have to change as well, and I actually don't even know how many there will be until I do them, so I'll probably only do a few and leave you to do some. So I just have my empty kind of structure here. Now I need to go look at Wikipedia to find Stirling's approximation. I already have that open in another tab, so I'll move it here. And if you just read a little bit of this, you'll find that right away, this is the part that is the more precise formula. And we'll just kind of go ahead and zoom in so you can see it. It's in factorial, and then it's about the square root, like it's asymptotically following the square root of 2 pi n. So we see 2 pi n is all under the square root sign, which means we're going to have to use some curly brackets around it. There's this parentheses, and we see that they're sized according to the fraction, and that's where you want to use that left and right command by a parenthesis to size it around the fraction. We have a fraction environment, and we have a power. So we have n over e raised to the n power. So if we take all that information and what we've seen earlier in this video, then we should go here and say, okay, well, we want n factorial. So let's just n with an exclamation point. We really haven't seen this symbol yet, which it looked like it was for the asymptotic symbol there. So that was this sim. The nice thing, by the way, you might notice this. I'm not sure if this pop-up will show in the video, but if when you're in a tech environment in Markdown, and this is a Google Colab thing, if I do backslash and then I start typing something, like I do the S and then the I, like it starts to show me what various options are for me to then complete my typing for that command, which I could just click on something. So it's actually yeah. Oh, it just put the symbol in there. Oh, I didn't even know it would do that. I just saw something. Well, I don't like, I actually want it to be the actual text. So it's backslash sim, S-I-M, will give you that kind of tilde in the center that you want for this formula. So we'll just put that there. And it was, again, the square root. You may not remember this. You can always go back and forth. But it's the square root of 2 pi n. So we're going to take the square root of 2 pi n. And now, of course, right, in curly brackets, I group the 2 pi n. Pi is the Greek letter pi. So I do backslash pi for it to format correctly. I now know that I'm going to have a left paren and a right paren to size correctly around a fraction. And then in curly brackets, I will put the numerator, and in other curly brackets, I'll put the denominator. And in the numerator, it's n, and the denominator, it's e. So n and e. And I'll just go ahead and fix some of my formatting there. You can have white spaces, that's fine. White spaces don't change anything about how the display is, but for readability, if it helps, you can go ahead and put some white spaces in. I often do like maybe one white space. I will point out, by the way, after the backslash pi, you need a space before you type something else, unless the other thing has a backslash next to it. Otherwise, if I just did this, it'd be like, oh, what's backslash pin? Well, backslash pin is nothing. Backslash pi times n, however, is what we're after. All right, now let's go back to here, raise it to the power, I think it was to the power n. Let me go double check. Yes, to the power n. So there you go, that's Stirling's approximation. And now, you should say something like, where, like pi is pi, the ratio, like, you can just copy basically what I wrote here. It's the same thing. The E is the same thing too, that we have. And so that pretty much is about all the things you need to know. I assume that people know what factorial means in the square root, but if you don't, then those are good things to add to the bullet list as well, to look those up, like what a factorial is and what a square root is. I hope everyone knows that. But anyways, that's basically how you get most of this activity done. I want you to do this in another format. So either format 3 or format 1. I've shown format 2. You could do format 1 and format 3. You don't have to do format 2. That's just what I'm showing here. And then you just have to do, the bullet points to just make sure that you're explaining what the different variables mean in that approximation. So I'll leave the rest of that, the rest of part A for you to finish. As far as part B, I have this link here that you can click to for the logistic function to typeset both the differential equation for population growth as well as the solution. I'm going to go ahead and just show you what these are, and just remember to use a bullet list to describe what each term means, like a variable in there. So if I click on this link, it should open up the logistic function. And so here's this differential equation. dp dt equals rp times this fraction. Notice the size of the parenthesis. I said fraction, excuse me, times this term that's in the parentheses, and the parentheses are sized rather like large. They're sized around what that fraction is, so you should use the left and the right command. Here, this should just be a frac command, like the \frac, and then you just put dp and dt in the numerator and denominator parts respectively. There's another fraction here. That's pretty straightforward. I want you to try that. I'll definitely give you feedback if you're struggling with it or help on Canvas in the course. And then of course the solution, I point out here, you can use either of the solution forms you want. So you could choose to write out this entire equation. This is the solution. You could just write P of t equals one of these. If you're going to do just one of them and you want the simpler one, obviously this first one is much simpler, I think, to tech out than this one. But this one's a really good, like if you can get this, then your tech skills are pretty solid because it's a fraction and it has a fraction in the denominator. And then that's a good one. I think if you can do that, your tech skills are, pretty solid. You're learning and you're at least demonstrating that you have a pretty good sophisticated skill set with the teching. So give it a try. But if you're struggling with this, go ahead and just do this one. If you try both, I certainly recommend that. And if this one's correct, and again, you have the bullet list, you finish the activity, I can give you full credit even if you mess up on this one, and I can just give you some pointers about how to fix this one in class. But that's it. I'm going to end the video there. Thanks for listening.